Hi guys, and welcome back to a brand new video. So in today's video, we're going to do some tests for our Lexer. So if you followed along, we've created the function that creates a Lexer. We've created a function that will read the current character. We've also created a function that will check the next token in the input. So we've done most of the stuff needed to create a simple Lexer. So all we need to do now is create some tests. Now, I was going to do that using Google Tests, as you've seen from the last video, but when looking up some of the stuff, I realized, when I was looking at ways in which we can test our input, I realized that like looking at Google Test, all it's doing is a simple assert. So I thought, why not just create a main program that will run the checks without having to use Google Test or any C++ frameworks. There's also a C testing framework, which makes sense. It would have made no sense for there to be no C testing framework or Unity, which is pretty straightforward apparently. So that's something we could look at adding in the future, and it is something that I want to do, but I don't think it's a requirement yet, so I'm gonna like kind of hold fire with that. So the first thing we're gonna do then is do the main.c. Now, somebody really did point out a few mistakes from the last video, and I picked them up as well very shortly after recording the second video. So I've made some comments here, so we're going to go through and correct them. Okay, so if you're following along, okay, we need to change this to Lexer, not input. Effectively, I mean, somebody made a comment on the previous video about it. I'll see if I can find it really quickly before we continue. Right, so I found the comment. So here, Daniel Feltonia pointed out that we've allocated memory for the size of the input string for the struct. This is probably an oversight since the total allocated memory would be consumed by the input parameter alone. So again, you know, that's something that was well spotted. If anyone catches any mistakes or any more efficient ways of doing things, just please let me know, because again, this is new to me. Something that I didn't do as well is the input length isn't the length of, which is the size of the Lexer. It's actually going to be str length. And we're going to pass through the input then. Okay, so effectively the length of the input, so string length input is going to be the length of our input, rather than the length of, which is the size of the Lexer. So we sorted that out, and then the last one we need to do then is simply call read char and pass L through, because we set everything to null, and now what we wanted to do is effectively set it to the values of the input itself. I think, yeah, so we want to get effectively assign read position and position. So position will look at the current character, read position is going to look at one ahead. So that's most of the mistakes done, I think. One more as well is break. Don't think this was as important, but it's something we need to add. We're going to add in, just keep things consistent. So if we do that now, something we can add in. By the way, you know, again, once we've done this, completed this episode, we've effectively created a basic Lexer, which is, you know, a big accomplishment, because, you know, it's not, I won't say it's not an easy task, because it has been pretty straightforward, considering, you know, we've just followed along with the book and it's pretty easy. I did put a link to in the description to the guy who kind of inspired certain ways of doing things. Again, it's learning a bit about the C-isms, I guess you can call them, where C is a unique language, and, you know, there's ways about doing things in C, and I'll give you a good example of that when we come to create the testing framework. So first things first, though, let's get this finished. Sorry, I know this is repetitive. Feel free to skip ahead as much as you need to. But I think that's it, though. Once we've done that, we've pretty much got everything working fine. So that's good. And then the next thing we're going to do then is go into our main file. And there's actually one more thing that I just remembered, which is we have to go to our header file and add some things in, just to make that more clear. So if I go to, right, I fixed that in the last episode, I believe. So struct Lexer. So we needed to effectively remove typedef from this file. So please make sure you've done that. That might come up as a possible error. But something I also need to do is go to here and add in our functions. But before we do that, I think it's best that we just input some of this into our main, include all the relevant files and such like that. So we're going to do standard input output library. We're also going to do, I think, include, I think we're gonna need to do, well, we're gonna need to do assert, that's for sure, because we're gonna be doing asserts for our tests. I don't know if this is like, this is a question I have to someone who's watching this now, if anyone is in the know. What, like, I understand the point of unit tests, and I understand the point of, you know, effectively using unit tests to test the things work as we expect them to. I completely get that. But what is the advantage of using a testing framework like Google Test versus doing what I'm doing now, especially in C? I feel like it's just, if you're familiar with stuff like, you know, unit testing, and you've done a lot of C++ and a lot of C, and you know how the languages interact with each other, I can understand that it'd be like an easy thing for you to do off the cuff, especially if you understand C makefiles and all that. But for someone like me, like a beginner or an amateur C programmer, I don't get the value at the moment. So again, it's something I'll have to do a bit of research on. I'm sure there are you know, values to do that. We're going to include standard library as well. Just not sure we'll need it, but we'll just add it in because I got a feeling that we always end up using it. Right, the next one then. Yeah, but no, I don't understand the value though, personally, of doing that. So again, something we'll have to have a look at. We're going to include header, no, Lexer.it. Right, awesome. Okay, int main. We knew this was coming. And then, there we go. Right, okay. Right, so let's have a think about what we need to do. So, we need to create our expected tests, which we're going to put in an array. It's going to be an array full of token types, so we need to get that done. Trying to think what else we need to do before we do that. Probably, right, let's do that first. We'll create our expected, so it's going to be token type, and then we're going to call it expected. It's going to be expected input, and then, sorry, I got to look on my keyboard for some of these. Right, there we go. And then I believe it's this for, right? So we're going to do, right, that's something I haven't done, is create the actual the actual input itself, right? So const char, and then we'll do, what should we call this? We'll call it input, and then we will assign the values. I don't know whether, yeah, right, okay, we'll do, okay, I may as well, right, what I'll do is I'll go grab the book quickly and see what input it gives for the first test, and we'll just follow along with the book as best we can. Right, okay, I'm back. So what we need to do, hopefully that wasn't bothering the mic. Right, we want to test, right, we're going to do assign, so plus, we're going to do left paren, right paren, left brace, right brace, and we'll do comma, semicolon. Right, okay. So we've got a test there, and now what we need to do is effectively put these enums, or what we are expected to test, or what we're expected to come back from that, in here. So we'll do token type assign. I don't know why that's not coming up as, that's interesting. Why is that not coming up as recognized as a token type? That's strange. Okay, let's go, oops. If we go to here, token type. Okay, maybe if we just save this file first. So if I just do, is that doing it? Okay, that's very strange. Oh, right, okay. It's not strange at all. We missed out the semicolon there. Right, we'll do that, scroll down. Okay, great. So we've got token type assign. Again, it's gone weird, is it? Is it meant to be in? Right, I think I know why. we're going to do equals, and then we can put it in. Or is it just no? Okay, right, we'll leave it like that for now because it's working. Token type plus. That's not right. Why is it not right? Okay, that's strange. All right, okay, let's do that. Do delete. Okay, there we are. Yeah, that is right. Okay, I thought so. I thought it was going crazy. Right, token type. You can again skip through this if you feel like you know, alparen. And then what we're going to do after this is actually calculate the, like, we have to calculate how many elements there are in the list. And there's a tricky way of doing it. And that's what I was going to say about the C-isms. They're just very strange. So if I do r_n, and then we'll do token type left brace. Yeah, just do this much quicker. Left brace. And the order, by the way, does matter, so please make sure, if you're following along, just make sure that you know what you're doing. So we'll do R brace, and then token type comma, and then token type semicolon. Awesome. Okay, so that's great. So that's all done. Now, this is where the C-isms come in. And again, got to do a semicolon here. Here's where the C-isms come in. So we want to do, right, size T. That's what we need to include as well. The size int, we'll do that shortly. We're going to say size T len equals, equals size of, and I'll explain this as best I can after as well. So size of the expected divided by size of, I'm going to do size of expected, and then we'll do 0. Okay, so let's see if I can explain it. So let's see if we've got any errors come up here. We haven't at the moment, which is great. Right, okay. So we have the size of our expected, which is an array, and that will add up to, I believe it's 4 bytes per enum. So each enum is worth 4 bytes. So what we're doing is we're doing size of expected, which is going to be 4 times 1, 2, 3, 4, 5, 6, 7, 8. So 4 times 8, 32. So this is effectively 32 divided by one of the elements, which is going to be, of course, 4 bytes. So effectively, all of these add up to 32. One of them adds up to 4. We do 32 divided by 4, which is going to give us the 8 elements that are in our expected output. And then we can use that then in a for loop, which is what we're going to do now. And hopefully we can get it working. So we got to do, first of all, let's create our Lexer. So we're going to do Lexer, we'll call it L equals, and then we're going to do new. Should come up, I think. New? Okay, might not. I think it hasn't come up because we haven't included it in our lex.h file, but we'll do that shortly. And then we're going to do, what are we going to pass through? Input in here. So let's go add that into our lexer.h file. And that is why I had this here. So we'll do that. But yeah, it's quite, I feel like this way is much easier it's a much easier way of doing it. I know, and again, like there's things in Google Test, like you have a test suite and a test name. So I can understand the value of that. You know, we have a collection of tests here and we've got the documentation to show that it works. But again, I don't get why we can't, if for this case, I feel like this is much more of an efficient way of doing it. But if anyone's got any idea about that, then please let me know. So I could actually probably just copy this. So if I go down here and we'll escape, yank that, go to here, paste that in, paste that in, and we'll go here and delete that. What am I doing? Delete. Okay, so I think that's fine. So if I write that now, no, escape. Hello, there we go. So if I write that and then we go back here, that should work fine now. And I don't know if there's anything else we need to do it for, but we can worry about that after. So now here comes, okay, no, actually one more thing we're going to do, and this is where the asserts come in, is we are going to do, what are we going to do? We need to do assert, and we need to make sure that our Lexer is not equal to null. And we'll do for, right, okay, for I, or int I equals 0. And then we'll do I is less than, no, I is, until I is greater than expected length. Oh no, just length, okay. Can't remember what I called that. And then we're going to do I plus plus. So we're going to increment, go through it. Okay, right. Right. So there's a few things we've got to do in here then. We've got to effectively set our token to be equal to next token. See, I don't know why it's not recognizing. I don't know if this is something I need to include as well. We're going to pass through Lexer in there. And then what we want to do after that is we want to check that our, right, we're going to do an assert to ensure that the token does actually exist. So we're going to say token is not equal to null. I always forget if it's the other way around. Does it need to be assert token is equal to null? Is the assert checking that is that checking that it's not equal to null, or should I have it the other way around to say assert token equal to null? We'll find out now. It shouldn't work if it's the other way around. Okay, and then the last one then, assert token type is equal to, if it is the way that I want it to be, is equal to, oops, token type is equal to I feel like I've done this wrong as well, isn't it? Yeah, we've got to do equals, or toke is equal to next token, and then we should say the toke type is equal to expected, and then I should be in there then, expected, and then we'll have I in there. Have I spelt expected wrong? For some reason it feels, no. Okay. And then the last thing we want to do then is, because we haven't done any cleanup of the tokens, we're going to do free and we're going to put token in there. So I think that's fine. And should that all work, we'll have a simple message that'll say print, and then we'll say tokens passed the test. Simple like that. Oops. There we go. Great. So if I escape, I've got a few errors. Not expected. Okay, right. This is quite a simple fix, I think. We want to check that our L is not equal to null. Does that work? That works. And the same here then. We're going to do toke. And here is going to be printf. What's funny is I literally done a little bit of Python, very little Python, a little bit of Python last night, and I think that just is why I'd done print instead of printf. Right, okay, so that should work now, I think. So let's try it, let's give it a go. And if it doesn't work, it's fine. We'll debug, we'll do all we need to do. So we'll do clang. What are we going to put in there? We're going to put in, actually no, wasn't there something I needed to include in this? nextToken. Isn't that something that, I don't know if that's something that is called within something. Okay, well, we've got a few errors here. Rechar, all right, yeah, so we need to set up rechar up here as well. So we'll do void read char, which is going to take in Lexer, pointer to L, and then that should be fine. Got a semicolon here. Okay, that's fine. Great stuff. And then, yeah, I feel like, do I have to include nextToken, or is nextToken called inside something? I forget if there's, nextToken is called inside. No, I think I need to include nextToken as well, so we can yank that. What have I done? Undo. Okay, let's do that. And then, okay. Oh wait, we can just include this at the bottom, that's fine. Let's do that. And then, paste. Oh no, I've already included that. Okay, that's fine. Okay, I must have done that in prep. I can't remember. Right, okay, if we just do this, then let's see if it works. So, right, quit, and then we'll do clang lexer.c main.c, and we'll call it LT for Lexer tests. Okay, we've got no errors, it's always a good sign. Lexer tests. Perfect. Okay, that's really good. Okay, so effectively we've got everything working. At least that could be a false positive, I don't know, but it looks like everything's working fine. So again, I'll try and explain this as best I can. Okay, so all we've done is we've got our input, which is effectively the input that we want to test for our new programming language. Will we go that far with it? I don't know, probably not, but it's fine. We don't have to necessarily. So we've got our input, which is going to be equals plus left parent, right parent, so on. We create the expected output, so effectively what we're expecting our program to give back to us, which is assign for the assign operator, plus for the plus, and so on and so forth. The order matters again, so if you're new to creating Lexer, the order is very important because we're expecting it to be given back in this particular order. This is effectively just working out the size of our array. So again, size of our array. I'm going to upload this to GitHub now that we've actually got something up and running. So I'll leave the link to the description in the comment section below. We have created our Lexer. We're ensuring that the Lexer is not equal to null. So that's our assert. That's effectively just going to run a check. It's going to ensure that our Lexer is not equal to null. If it is, it's going to crash the program. Then what we do is we're looping through. We're saying I is equal to 0. This is the first element in our list. And whilst I is less than the length, we're going to effectively go through. Should it be less than or equal to? I think that's fine. I think it's just less than. While I is less than the length, it's going to go through and increment I each time. So effectively, we're going to go through our expected input. And then once we've done that, as we're iterating through, we're calling nextToken in our Lexer. And we are asserting, we're ensuring that the token is not equal to null. So effectively that we're not getting, we're ensuring that we are getting a token back. And then we're also checking then that our token type is equal to the expected token. And of course, I is representing whatever iteration we're going through that list. Finally then, if that all works and our asserts don't fail us, we get the pass, so we get the all clear. I think that's fine. I think that works. There's probably more checks we could do, but we'll leave them for future episodes. And what I also want to do, again, I mean, it all depends on what people think of this series. If they want me to carry on, there's a lot more we can do. We can add in, effectively, we can add in more to do with like removing white space, so skipping white space. We can add, the peak char function, which will effectively allow us to check for not equals to and so on. Happy to do all that, but it depends on the support that we get for this channel. Something that I'm really interested in, something I wanted to try, which is something I've seen Ginger Bill talk about again on the Wocash podcast, which again, fantastic, really recommend you watch it, is effectively going through each, there's more steps to this which we're going to go through, but something that he suggested that is something everyone should learn to do is how to parse JSON. I would like to do that before I move on to parsing the tokens in this language that we're going to create, if we ever do go through with it that far. So thank you for watching. Hopefully you enjoyed. Apologies if I sound tired. I've literally had not as much sleep as normal, but it's fine. Really enjoying making this project, and it's fun to have something actually up and running and something that I actually understand how it works, and something that use header files as well. Again, we're just slowly building these skills, building up these skills in terms of a full-fledged project. But yeah, thank you for watching. I look forward to seeing you in the next episode, and so long.